Welcome back to another exciting math video. I know you're all just on the edge of your seats. Today we're going to be solving one-step equations. So today in class we did modeling equations, and now we're going to be stepping up in solving an equation for the variable, but it's only going to involve one step or one operation. So our learning target, as always, is SOL 714. We're going to be solving one and two-step linear equations with one variable, and also solving practical problems requiring the solution of one and two-step linear equations. So if you remember in class today, I talked about practical applications for when we're solving equations. You use this every day, you just don't realize that you're solving an equation. So, for example, if you look at my pictures here, I've got your little tiny sister who's so annoying. You made all these cake pops for you're in the process of making cake pops for your class, for your birthday party, and she came and she ate 5 of them. But you couldn't remember how many you'd already made, so you would use an equation to figure out how many you had made and how many you still need to make. So those are the kinds of problems that you would face. I'm going to show you a really quick video. That's a Bill Nye clip of him solving for X in a cupcake shop. So just hold on and I'll get it up and running for you. Okay, welcome back. I just wanted to show you that really quick video of Bill Nye so you could see a practical application. He wanted to find out how many cupcakes were in each box. That problem that he was actually doing was a little bit more complicated than what we have to do and what we're doing today, so I didn't want to show you the whole thing and get you confused. So, but you can see a practical application of when that might be useful. All right, break out your notes. We're on page 12. Should say one-step equation notes at the very top. We're going to start by talking about what's our goal. Our goal of solving an equation is to find the value of the variable. So in Bill Nye's case, it was solving for the variable x. Sometimes your variable is x, sometimes it's y, sometimes it's c. We don't know. Sometimes they use different letters. But our ultimate goal always is to find out what does that variable mean? What number does it represent? And that is the whole goal of algebra. And in order to do that, we have to get the variable by itself, or the letter by itself. To do that, we have to perform the inverse operation. So if we talk about this, we talked about it in class today, but what is the inverse of addition? Subtraction. So when we want to undo addition, we subtract. What is the opposite or inverse of subtraction? Addition. Likewise, what is the inverse of multiplication? Division. And the inverse of division is multiplication. So it's important that you understand those, and we're going to talk about some special situations in just a minute, but I wanted to make sure you understand the inverse. So the inverse of addition is subtraction, the inverse of subtraction is addition, the inverse of multiplication is division, and the inverse of division is multiplication. All right, so let's look at some examples. And basically all we're doing is using the inverse operation to solve for the letter. So if you look at our first example, we want to start on the side with the letter. So that means I'm starting on this side that says b plus 14 equals 27. Basically, I look what's being done. I have a positive 14. The inverse of a positive 14 is a negative 14. Remember, we divide the problem in half at the equal sign because there's two sides to that equation. There's a right side and a left side. Whatever I do to the one side, I have to do on the other side to keep it balanced. If you remember the video we watched in class and the video you watched last time, we always have to keep the equation balanced. That's why we have an equal sign. Going back to our example, we have b plus 14, and now we're subtracting 14. A 14 minus 14 gives me 0. So on this side, I'm going to have b plus 0. And on this side, on the right side, I'll have 27 minus 14. 7 minus 4 is 3. 2 minus 1 is 1. So I know that b plus 0 equals 13. Well, anything plus 0 is just itself. That's our identity of addition or additive identity property. So I know that b is equal to 13. The nice thing about equations is it has a built-in check system. If you remember when we were doing when we learned order of operations, we also learned to substitute values in for the letters. Well, this allows us to check our answer. So if we rewrite the equation, b plus 14 equals 27, and I go back where b is and put those parentheses like we practiced, and then now I'm saying b is equal to 13. So instead of b, I'm going to write 13. Now if I add on the left side, 13 plus 14, well, 3 plus 4 is 7, 1 plus 1 is 2, I get 27. 27, does it equal 27? It does, and that tells me this check step allows me to check my answer and say, yes, 13 does make sense. A lot of students will want to rush through this process and they don't want to do the check step, or they only half-heartedly do it and they just write down numbers so it looks like they checked their work. But if you actually plug it in and check your work, you will never ever miss a problem and you'll always get it right, because that check step checks to make sure your answer works. And if you do it right, then you'll get the right answer all the time. If you look at number 2, our example here, we have a little step we have to do first. If you remember back to our integers, we can't have double signs. So here we have -5 equals w minus a -4. Well, I know that minus a negative, if you remember back to your integer guy, if I have a negative and a negative, that changes to a positive. So I'm going to change that to a positive. So it would actually be -5 equals w plus 4. And now I'm going to divide my problem in half. So I have two sides to the equation, and I'm working on the side with the w, not on the left side. Don't assume that you're always going to be solving it on the left. So I need to get rid of that number that's with the W. So how do I do that? If it's a positive 4, I want to undo it with the opposite, which is a negative 4. So I'm going to do that on both sides. Whatever I do to one side, I have to do to the other. Positive 4 and a negative 4 equals 0. So now I have W plus 0 equals, and if you think of your battle boxes here, I have a negative 5, which goes in the negative box, and a negative 4, which goes in the negative box. If they're all in the same side, then I simply add them up. 5 plus 4 is 9, and they're in the negative side, so it's a negative 9. Anything plus 0 is just itself. So now I know that W equals negative 9. And I can plug it back in by rewriting my equation. Negative 5, and I'm going to rewrite it without the double negative since I know I have to do that anyway. So instead of W, I'm going to replace that with a negative 9. So now, let's use my battle boxes again. I have a negative 9, which goes in this box, and a positive 4, which goes in the positive box. And I need to say which box has more. The negative side does. And how much more? 9 minus 4 is 5, so I know it has 5 more. Does negative 5 equal negative 5? It sure does. I know that my answer is correct. And if you remember in that video we watched today in class, he says always circle your answer. I don't understand why you wouldn't. This, by circling your answer, this is your answer. This is your solution to your equation. The check step is just your way of checking to make sure you got it right, but this is actually your solution. So by circling that, then I can clearly see that you're telling me that the answer is negative 9. So let's look at our next example. This one is a little bit different. If you look, there's no positive sign, there's no addition sign, there's no negative sign. So this is just the number of the problem, so ignore that. I have 7s, and we know that 7s means multiplication. So the opposite, or to undo the multiplication, I have to do the opposite, which is to divide. So I'm going to divide each side by the number being multiplied times the letter. So if we look, where's our letter? Our letter's right here. So the number being multiplied times the letter is 7. So I'm going to divide by 7. Whatever I do to one side, I have to do to the other. So now 7 divided by 7 is 1s. 56 divided by 7 is 8. Anything times 1 is just itself. That's the multiplicative property, identity property. So we know that s equals 8. And we can check this one just like we checked the other ones by rewriting the equation. But in place of s, I'm now going to put my solution. And I said that s was 8. So what is 7 times 8? That's 56. Does 56 equal 56? So all I did was plug that in, and it does, so I know my answer is correct. My next example, again, this is just the number of the problem, so you can ignore it. This means I'm dividing. So the opposite, or the inverse of dividing, is to multiply. So to solve this one, I'm going to multiply by the number that's being divided. So here's the side that I'm looking at, because that's the side with the letter. The number being divided by, or the number I'm dividing by, is 6, so I'm going to multiply by 6. So I'm multiplying both sides by 6. That gives me 6 over 1 times 1 over 6r equals 3 times 6. 6 times 1 is 6. 1 times 6 is 6. So I end up with 6 over 6r. So these are my two sides. And over here I end up with 18. 6 over 6 is the same thing as 1, And I know 1 times r is just r, so my answer is r equals 18. Let's plug that in and see if that works. So again, just rewrite your equation. R divided by 6 equals 3. And instead of r, I'm going to plug my answer back in. So I said r equals 18. So let's plug that in. 18 divided by 6, well, that equals 3. And my answer I was looking for is 3, so I know that's correct. All right, let's keep moving down. All right, number 5. This one looks a little bit different. So I'm going to rewrite this one just so I have enough room to do my work. This is saying half of a number, I don't know what that number is, it's C, is equal to 12. So what is the inverse of a half? Well, we kind of talked about that. What is the inverse of a half? Well, in order to do that, I would have to double it. So that is multiplying by the inverse, which is 2 over 1. Whatever I do to one side, I have to do to the other. So I'm going to multiply by 2 over 1 over here. 2 times 1 is 2. 1 times 2 is 2. And again, I'm still just multiplying by C. And then I have, let's make that a fraction, 12 over 1 times 2 over 1. 12 times 2 is 24. 1 times 1 is 1. And then I can simplify by getting rid of my fractions. 2 over 2 is the same thing as 1. 1c is the same thing as c. 24 divided by 1 is just 24. So my answer is 24. Let's check that out and see if that works. So 1/2 of c equals 12. Well, if I get rid of c and I plug in the answer that I got, which was 24, they're saying half of 24. Well, half of 24 is 12. But if you're looking to see how that works mathematically, 1/2, and we have to make 24 a fraction by putting it over 1. 1 times 24 is 24. 2 times 1 is 2. 24 divided by 2, that equals 12. So either way, you're going to get the same answer, but that shows that it is correct. Okay, let's look at our last one on the first page. It's a little backwards, so we have 9 equals negative 3w, so where's my variable? It's right here. Now I have to ask myself what's being done. I have negative 3, it's not subtracting 3, that's a negative 3 times w. So to undo that, I have to use the opposite of multiplication, which is division. So I'm going to divide, here's my two sides, and I have to divide by exactly what's being multiplied. And in this case, it's a negative 3. So I have to divide by a negative 3. So if I divide by negative 3 here, I have to divide by negative 3 here. And I'm going to put, if you remember tic-tac-toe board, or you can use integer Bob, whatever you want to use, because this is where our integers are going to come into play. I have a negative divided by a negative on this side. That gives me a positive, because a negative divided by a negative is a positive. So a negative 3 divided by a negative 3 gives me a positive 1w. And then I have a 9 divided by a negative 3. That's a positive divided by a negative, which gives me a negative answer. So my answer is negative, and then 9 divided by 3 is 3. So 1w is the same as just w. That means I've got 1w. So my answer is w equals a negative 3. And I can check that by plugging it back in. Instead of writing w, I'm just going to put my parentheses and plug in what I have. W equals negative 3. So over here I have negative 9. Negative times a negative. Oops. Sorry, that's wrong. This is a positive 9. A negative times a negative, if you look back over here, that is a positive. Sorry, this should be positive. So I get a positive 9 over there, so I know that my answer is correct. Okay, so you can see how we're taking everything we've learned so far. We are seeing how we took the modeling examples, how we're using our integer rules, and we're using our inverse and our properties and taking it all and putting it together. So let's look at a couple more examples on the back. We have v minus 10 equals a negative 9. Go ahead and start by dividing your equation. I'm going to highlight where my variable is so I know which side I need to work on. I have v minus 10. The inverse of minus or subtraction is addition, so I'm going to add 10 to this side, add 10 to this side. So now I have v plus 0 equals, and here I need to use my battle boxes because I can't remember all my rules. You can use a calculator here, but you have to remember when you're inputting things, sometimes you need to put that negative sign after. So in this case, my 10 is positive and my 9 is negative. Which one has more? My positive does. How much more? 10 minus 9 is 1, so my answer is positive 1. Anything plus 0 is just itself, so that's my identity property. V equals 1. Now in this one, I didn't give you a check space, but you can go ahead and add it in, and I would recommend this. So let's do our check step. Rewrite your equation. I'm going to take my V out, plug in my new value, which was 1. 1 minus 10, if I use my battle boxes or a calculator, I have a positive 1 and a negative 10. Sorry, that's supposed to be 10. Which one has more? My negative. How much more? 10 minus 1 is 9. So my answer is negative 9. Negative 9 equals negative 9, so I know my answer is correct. On the next one, what's being done? Right now I'm dividing. I'm looking at this side of the equation. So in order to undo division, I'm going to rewrite it just so I can show my multiplication without my number getting in the way. I'm going to multiply by the number being divided by, which is 5. So I'm multiplying each side by 5. That gives me 5 over 5x equals 2 times 5, which is 10. 5 over 5 is the same as 1x, so that just means x equals 10. And I can check that. Here's my check step. I'm going to plug it back in where my x is, put my parentheses. So now I take my 10 and plug it back in. 10 divided by 5, well, I know that's 2. Okay, so I'm not going to continue solving these because they're more of the same kind of thing. I am going to ask you questions about them so that you can answer those questions on Edmodo. I will post the answer key so you have what you need if you don't understand. But remember, it's always just using the opposite operation. Make sure that if you're looking at it, that you're circling or highlighting the side with the variable and you're asking yourself what's being done. In this case, I have negative 11 right next to a K. There's no subtraction sign, there's no addition sign, so I know that it has to be either multiplication or division. I never write division this way, so I know it has to be multiplication. How do I undo multiplication? I use its inverse operation, which is division. Looking at number 4, I have an addition sign, x plus 4. The opposite of adding 4, subtracting 4. So you can do that if you take a minute and don't get confused. Don't assume that when I have a negative sign, that means I'm subtracting. Sometimes it does, sometimes it doesn't. If it's out in front like this one on number 3 where you have a negative 11k, that is not being subtracted. That is being multiplied. That's a negative 11 being multiplied by a k. So be careful as you're solving this. I will get the quiz uploaded and get the answer keys uploaded and things like that, so that'll help you. Please make sure you're taking notes. Make sure you're watching the video completely. And I will be checking next time. Don't forget we've got a quiz, so you want to be studying and make sure you have if you have questions, you ask. Have a great weekend, and I will see you guys on Monday.